During this lecture, we'll be talking about the alleles within alleles concept. Now, first of all, to understand this whole concept, let's take examples and branch off from there because this is going to be the most effective way. Now, the example we're going to be taking in this video are the rosy phenotypes in Drosophila, where the wild type, the RY positive, are going to be coding for red eyes in the Drosophila, and the rosy flies, the RY negative, are going to be having pink eyes. Now, the gene that we're going to be talking about in this video is the RY gene, which codes for the enzyme xanthine dehydrogenase. Now, it is worth noting here that it is a dimer, and this is going to be very important in our analysis of the gel electrophoresis gel later on. Now, moving on, we've got the RY positive / RY positive alleles are going to be having high activity. The RY positive / RY negative are going to be having intermediate activity, whereas the RY negative are going to be showing no activity. And this also is going to be very critical in our gel electrophoresis analysis later. Now, within the rosy alleles, there are two major versions, and let's try to, in order to clarify this, let's represent them as chains because that's what they are. They have one chain that is going to be moving rather fast on the gel electrophoresis, and this is why we represent this as F, which represents fast, and S chain, which is the slow. So within the RY positive alleles, we're going to be having two chains, one that is fast and one that is slow. Now, there are three different genotypes, if you want, that can stem from these two chains, which are obviously the F/F or the F/S and the S/S. Now, do we just have to note here that these are only present within the wild type RY positive genotype. So, just like we earlier mentioned, we said that the F chain is going to be the fastest, and just like we're seeing in the image here, we have the F/F band is going to be migrating as far along the gel electrophoresis as possible. It is going to be the one that migrates the most, whereas the S/S, which is the slow chain, it is going to be migrating less. Recall that the gel electrophoresis, the movement of the bands within the gel electrophoresis happens from the top to the bottom. Now, also within the middle, we've got the F/S chains, and this is normal because we have a mix between the F chains and the S chains, which is going to be having an intermediate effect. Therefore, the bands are not going to be neither present nor in the bottom nor in the top and the bottom of the container or the top of the gel. Now, moving on, in order to calculate the genotype and the allele frequencies, we have to simply assume that P is equal to the frequency of F is going to be represented as that letter P, and Q is going to be representing the frequency of the S chain, and R is going to be representing the frequency of the RY allele. Now this is very important because now all we have to do is assume the Hardy-Weinberg law, and we can then use the P squared plus 2PQ plus Q squared formula in order to get all our values. Now, let's look at this image, and it's rather interesting when we are talking about the electrophoresis phenotypes of these Drosophila examples. First of all, in the one at the left-hand corner of this gel, we are going to be seeing the P squared plus 2PR, recalling that the P is going to be representing the F chain and the R is going to be representing the RY. So simply, we've got the F/F, since it has the highest, since it has all the fast chains, it is going to be moving the farthest, which makes sense. And we've got the F/RY. Now, it's maybe for a moment you might think that this is weird, but we recall that at the beginning of the lecture we mentioned that the RY has no activity. Therefore, the F, which represents the fast chain, it is going to be migrating, and the RY does not have any activity to slow it down. Therefore, they are going to be present at the same level. Next, we've got the 2PQ, which recall that P represents the F chain and the Q represents the S chain. Therefore, like we mentioned in the previous image, they are going to be having intermediate effects because the P is going to be fast and the S is going to be slow, and they're going to be having a meeting in the middle. And this is why we are going to be seeing three bands due to the differences in the frequencies of the F/S chains. Next, we've got the Q squared plus 2QR. Q represents the S chain and the R represents the RY. Now, just like we mentioned in the In the first example, the same thing is going to be happening here. The S/S is going to be having the slowest activity, therefore the slowest migration, and the S/RY is going to be having also the slowest because the RY possesses no activity. And in the final gel, we have the RY/RY. Now we see no bands, and we should see no bands because there is simply no activity that is happening in this area.